Hello, I'm Kevin Benedict, Senior Analyst for Digital Transformation with Cognizant, reporting live this week from New York City here at the Things Expo. And I have the privilege of having as my guest Nick Landry from Microsoft. Thanks for joining us, Nick.
Thanks for having me. It's great to be here.
Now, Nick is the Senior Technical Evangelist and covers what all things?
Basically cover mobile and cloud in general. Microsoft is basically a mobile-first, cloud-first company. So my role is to educate, speak, work on content, learn all the time.
All right, so since you and I have been having some really intense conversations about the Internet of Things, why don't we just start there?
Yeah, sure.
Yeah, talk to me about what's Microsoft's position around the Internet of Things? What have you guys done? What do you guys have, etc.?
Okay, well, in a nutshell, the Internet of Things is basically just a new term for something that's already been around for a while. So, for example, at Microsoft, we've been in this business for about 15 years now with a lot of our embedded products with Windows, Windows CE, Windows Embedded. And we've been working with a lot of different companies over the last 15 years in manufacturing, transportation, helping them connect their assembly lines, their patients, hospitals, equipment, and basically connect them with their internal systems. So it's a space we've been in for a while.
So you have embedded operating systems on machines and other kinds of things. What connects them all together?
Well, see, that's the thing, and that's where things are kind of evolving now. The Internet of Things says that everything has to be connected in one way, shape, or form. The Internet is kind of the central piece of it. And whereas these embedded systems used to be more like closed-loop systems where inside of an enterprise you would have your servers, your internal machines, your devices, and your embedded systems, now we're basically reaching out to smaller and smaller sensors because Moore's Law basically says that we have cheaper and more powerful sensors for basically either cheaper for the same size or smaller for the same price. And on the other side, we have the cloud, where now we can store ginormous amounts of data in the cloud, and that's where big data comes into play with analytics as well.
Very good. So does Microsoft have a dashboard that manages Internet of Things, or do you depend on partners for that?
Yes and no. Well, actually, I would say yes and yes. Definitely. Yes, we are relying on partners. That's the beauty of our Internet of Things strategy, is that it's all based on primarily existing systems, because that's what you want. The Internet of Things lives in a brownfield. You're going to work with existing computers, with existing assembly lines, with existing embedded systems. And now you might be adding more sensors and maybe connecting a few more things, but you're not going to scrap everything. So by relying on existing technologies that our partners are already familiar with, then it's a field that everybody can just enter, work with us, bring their customers, and then we'll be able to help them basically enable new scenarios. At the same time, we have Azure, which is a centerpiece of our strategy when it comes to collecting all this information and providing insights with like Power BI and HD Insights for analytics. And the way it works is that we can then create custom dashboards inside of Azure, and the dashboard itself can be anything. You can basically use the web. You can create like Windows Store apps. We also support very well Android and iOS and all. Anywhere you will want to consume this information, you'll be able to create a dashboard, whether it's for analyzing the data later or seeing it live in real time. And all of this is based on a new platform around Azure called Microsoft Azure Intelligent System Services.
Ah, very good. So for those that may not be familiar with the Internet of Things, where might they see connected devices around their life, around themselves, around their cars, homes, wherever? Where would they find those?
It's interesting because depending on who you ask, you're going to get very different definitions of the Internet of Things. If you go to like young startups and the maker space and everything, they'll say that because they're playing with an Arduino or a Raspberry Pi or a NetDuino, that they're in the Internet of Things space. And yes, they are. It's a small portion of it. It's basically the end of the line portion of it where you can create these smart systems, sensors connected. But there's an entire backend after that that's going to work with servers and the cloud. And so you're going to see a lot of these things. For example, home automation is one of the main areas where I would say everyday folks are looking to connect their lives. Something as simple as using a Fitbit to monitor the number of steps you have, or a heart rate monitor connected to your phone. These are all things where these are sensors. They're collecting data about your daily life. The temperature in your home that you can maybe remote control when you get back from a trip, so that you can turn on your AC when you're at the airport, not just when you walk at home. So again, it's a brownfield. The house is by definition not connected, and now you want to enable it for automation, then you're going to have to start working with what you have and integrate new systems as well.
Very good. You know, a lot of people don't realize how many sensors come in the average smartphone, and sensors that are monitoring all kinds of things. Can you give us, how many sensors do you think the average smartphone has?
Oh my God, let's see. So there's like a gyroscope, the accelerometers, there's going to be a light sensor. The screen itself is a sensor because it can actually measure touch that you have against it. There's a microphone, can capture sound as well. That's another sensor.
GPS?
Oh, of course, yeah. Let's not forget the GPS, and not just the GPS. Location services is going to be a combination of the GPS. The cell radio itself can do triangulation of positioning. That's another sensor in a way. And then you have the Wi-Fi, which can also be used for triangulation. So Wi-Fi can be used for communication, but it's also technically a location sensor as well. So yeah, the camera, that's a major sensor. Let's not forget the camera. So yeah, these devices are definitely awesome into playing into the Internet of Things, because it's not just about the Arduinos and the phones and embedded systems. It's about connecting all of them together. But you'll realize that some are going to be smarter than others. People keep talking about fridges and toasters. Yeah, you'll be able to put some maybe chips inside of toasters so that you'll know when your toast is ready, or get the weather so you can maybe print a weather pattern on your toast in the morning so you know what's going to be the weather in the afternoon. People are working on this. But you don't need to put an IP stack on your toaster, because first of all, that's going to bring the cost of the toaster way high, but you can still put some wireless technology in a toaster that will then communicate with another device that has an IP stack to communicate with the cloud from there.
Very good. You know, at the Mobile World Congress in Barcelona, Spain earlier this year, one of the coolest, I guess you would call it, sensors that I saw was a sled that would go on an iPhone, which was a thermal imager, so that you could, in the middle of the night, look at your backyard, and it would tell you if there was anything giving off heat signals from your backyard behind the rose bushes. So you hear sounds out there, you scan with your iPhone, and it would bring up the heat image of any object out in the back 40.
Well, this is an example where someone decided to put it in some kind of a sleeve for an iPhone. A more realistic scenario would be take the same sensor and then put it into a very, very small packaging that would then live in your backyard, that would have a battery that would be powered, solar powered during the daytime, so you never have to connect it. And then it might have then connectivity to send its data back, and then you can even pair it with a motion sensor so that you're not going to record basically all night long to see if there's anything going on. You're going to use maybe a motion sensor or a heat sensor to then decide, oh, now let's record because maybe there's something going on, and then you can have an infrared camera. So this is where the hacker space comes into play, taking all these different sensors, because you can go to a Maker Shed or Adafruit or basically all these different stores, or Amazon as well, where you can order these little sensors for only like $1 or $2 or $3, and order them and start connecting them on a Galileo or a Arduino or Raspberry Pi and create some pretty amazing things. And you're going to see us in that space as well. If you go to windowsondevices.com, you will actually see something. Since this is a video podcast, let's get the big guns out. You will actually see something really cool, like, for example, one of these.
You saw it here first.
There you go. So if you go, this is nothing like completely. We actually talked about this at Build. If you look at one of those tiny little things, this is an Intel Galileo board, and this is basically $70 it costs, but it's a full computer. We actually have a version of Windows running on this. I actually have Windows running on this right now, and it's going to become available to the public very.
And what is it the brains for?
So for anything you want, you can write your software, you build your software today with C++, later it's going to include WinRT as well, and it can go in use Visual Studio to build your app, and then that can be the brains for anything, because this is Arduino compatible, for example. You can then connect sensors to it.
So that means you'd plug into your car for something?
You can plug into your car, you can create a robot out of it. That could be, for example, if you put all these little sensors out in the field around your home or in your company, then they could then send wirelessly data to this, and then this would be the program. Maybe there would be some analysis on the sensor data that's coming in to decide, should we bother the cloud infrastructure with it? The best example I can give is if you have a temperature sensor that's supposed to measure, for example, a ball bearing box. It measures the temperature of the oil inside of it, and that temperature is supposed to be no higher than, I don't know, 100 degrees Fahrenheit. Pure number out of my head, like this. If the sensor is constantly returning 100, 100, 100, you don't care. you want to know when a sensor came online, when it came offline, and then if it starts going to 101, to 102, then a small board like this out there would be able to take the data and then start logging this in the cloud, and then someone monitoring this on a live station would then be able to see, okay, we have a problem that's going to come here. It's not a problem yet, but it might be. You know what your threshold is going to be. You know where the trend is going to go. You know how long it took to go from 101 to 102 to 103. So that's, instead of putting a full laptop in the field, you can use something like this.
So that theoretically could be your home automation system right there.
Yes, exactly. It's going to connect to your thermostat. It's going to connect maybe to systems on your locks, but you could have a central system. And then the cool thing is, this is a headless device. It doesn't have a screen, but you can use something like this to communicate with it, to then control it. So you have a piece of software running here. That's the Internet of Things. Bottom line, it's the Internet of your things, the ones that matter to you.
Very good. Nick, I want to thank you for joining us today, and I want to thank you guys for watching.